Hello and welcome to video 4. I don't know how many videos there's going to be, but I'm just going to keep making them until we are done. So let's just wait and see. I really don't want to make the videos too long, and I feel like I've gotten a lot of the background material covered now so that we can really just talk about the Hegarty questions. And I'm actually going to start with a question from task number 178. Which is this x over 4 equals 3 over 8 question. Now maybe you don't have this exact question, maybe you have something similar. It's just a good idea though that I talk about this one. So ignoring for the time being that we've got a kind of a whole number over here, right? It's not a whole number. It's not, you know, if it was If I put an easier question under here, imagine it said x over 4 was 5. Imagine it said that instead. Oh, that would be so much nicer. That would be so nice. We could go back to, I believe it's video number 1 or maybe video number 2. I think it's video number 2 actually, where I show you how you answer questions like this, right? You want to times both sides by 4 in order to answer this, because x is being divided by 4 and we're getting the answer of 5. So x is some bigger number than 5, some bigger number, and it is being divided by 4 and the answer is 5. So the question is well, what number when you divide it by 4 gives you 5? So you might be able to work out that that's 20. If you weren't sure, where's that 20 actually come from? Where's that answer come from? It's because to undo division by 4, you're going to times both sides by 4. So you get x equals whatever 5 times 4 is. And of course, that's where the 20 comes from. Now, we are going to apply the exact same logic up here, except instead of 5, which is a nice number, we have 3/8, which is not as nice. It's not that horrible, but it's not as nice because it's a fraction, not a whole number. What do you think are times both sides by? Do you think it matters that it's 3/8 and not 5? Would this have changed at all if instead of seeing 5 it had said 10? I mean, the answer would certainly be different, but would the method of timesing by 4 have been any different? No, I'm going to times both sides by 4 because that's what's going to give me whatever x is. So in the other color, by the way, I'm just kind of illustrating what it is we're going to do to both sides. When I actually times 3/8 by 4, I need to make sure I write that down neatly and correctly. So let me show you how we would write that. This is just x. So this bit's almost done. I need to work out what 3/8 times 4 is. Now, if you can't remember how to times a fraction by a whole number, or you certainly can't remember how to times a fraction by a fraction, this is clearly where I'm about to remind you. So in this situation, you would want to write the 4. I mean, you don't have to do it this way, but this is how most people, certainly at this stage of learning maths, how most people are going to approach this. They're going to write the 4 as a fraction with the 1 on the bottom. Because 4 divided by 1 is 4. I can write the number 4 as a fraction with a 4 on the top and a 1 on the bottom. So this is what I'm going to do. I'm going to write 3/8 times 4 over 1. So this is what a lot of people like to do when they're answering a question like this. They put a 1 on the bottom. Because timesing fractions is super simple, as long as you remember that it's super simple. You just times the tops together and you just times the bottoms together. So 3 times 4 is 12, 8 times 1 is 8. Of course, I could have thought about this up here. If I have 3/8 4 times, how many eighths am I going to have? So I've got a 3/8, another 3/8, another 3/8, and then the fourth and final 3/8. How many eighths will that be? So it's 3, then another 3, then another 3, and then another 3. So that's 12 of them. And we're counting how many eighths there were. So whichever way you like to think about it, I don't really mind. The answer is 12/8 for this one. If you look at what it says on Hegarty, though, it says it wants it in its simplest form. So we are going to have to work out what goes into 12 that also goes into 8. I want to pick the biggest number I can, if at all possible, right? So I can spot that 4 goes into both of these numbers. So 12 divided by 4 is 3, and 8 divided by 4 is 2. So I should just put 3/2. And then for this one, I'm not going to answer it. I'll just say out loud. So in this one, I would times both sides by 2, because it's the number that x is being divided by. So I would times both sides by 2. So I would do 2/1 times 2/5. And then I'd write down my answer and put it into Hegarty Maths. So anyway, that is task 178. I'm not going to say anything more about that now. I'm going to move on to task 179 and then hopefully keep this video a bit shorter. So, many of the skills that you've been taught, by the way, I think I need to refresh the page when it does this. Yeah. It's quite a few of the skills that you've been taught before to do with expanding brackets and things like that. They're relevant here because there's nothing to stop me putting brackets onto one or both of the sides. What you do is you would expand them out and then answer the question. So you can make these questions more complicated by putting additional steps in, but they are steps that you have been shown separately. But anyway, if we just look at this one's not even one with brackets. In fact, this is a one that we've literally seen how to do. So if I have 4x add 2 is 22, I'll pick this one to show you both methods, right? So I'll show you the bar method and I'll show you the balance method, and we'll see how they're going to give us the same answer. So there's a bar for the 4x add 2, and here's a bar for the number 22. So I guess the little bit there that's a 2 has to be small if I'm going to try to draw it even remotely accurately. Again, though, it doesn't actually matter. What is it that I'm supposed to do? Right, well, I cut off this 2 from both, and I guess that's not 22 anymore, is it? This bit that's left is 20 because I've taken off the 2, because really this bit here is a 2, isn't it? So this is now 20. And what am I left with? Well, the 4x is equal to 20. So now I do the normal thing, divide by 4, and so I get x is 5. Now, how would I have done this without the bar method? What if it had been more complicated and maybe I couldn't draw the bars? Well, let me just show you that now. So 4x add 2 is 22. I want the x's by themselves because the idea is at the end I'm going to divide by, well, in this situation I'm going to divide by 4 at the end. That's what's going to happen. So I want to get rid of the plus 2 that's next to it. Like, that's the idea. And that's actually what we did up here. Like, we got rid of the 2. So to get rid of the plus 2, I take away 2. And I do that from both sides of the equation. I keep the equation balanced. I did take away 2 from both of these. It wasn't just one of them. I chopped it off both of them. This is the same thing going on here. I'm just not drawing the bar. And so the 4x is still there, but the 2 and the minus 2 go. They disappear. It's gone to 0. And 22 take away 2 is 20. And of course, I'm actually literally at the same position that I got to. I just haven't, like, doing this is this orange chopping off the 2 bit of the bar drawing. So now I divide by 4 just like I did before, So x is 5, just like it was back then. So let's have a look at some more questions. 8x add 1 is minus 31. So I might not draw a bar for this one. I might just try to use the balance method. How do you want to approach this? What is it that you want at the end? What are you going to end up dividing by, do you think, in this question? So you're going to end up, right at the end, you're going to end up dividing by 8. Right? The number in front of the x. You want the 8x to be by itself on one side, so that at the end you can just divide both sides by 8 and be done. But this plus 1 is there, and we want to get rid of that. So that's what we're going to get rid of. Now it's very difficult to draw a bar for negative 31, so I'm going to avoid doing that. I'm going to write 8x add 1 is negative 31. I'm going to realize I want the 8x to be left by itself. I want that by itself, just one term with nothing else on that side. So I want to get rid of the plus 1. So what would we do to get rid of a plus 1? Ooh, I want to be consistent with my colors, so let me use the orange pen. I will take away 1 and then take away 1. So here I have 8x. That's what's left over. The plus 1 and the minus 1 have gone. They've disappeared, gone to 0. Here's where I have to be really careful though, because this is negative 31. Take away 1. So, maybe at this point in class, I might say, right, hands up if you think it's negative 30, hands up if you think it's negative 32. And then I would tell you that if you said it was negative 32, you were correct. Well done. Because you're down at negative 31 and you're going further down the number line by taking away 1. If I was really super organized and even better, and I mean, I might do this for future videos, I'd have a number line up on the screen, but you're just going to have to bear with me here. So if I'm down at negative 31 and I take away 1, I am going to land on negative 32. If I was at positive 31 and I took away 1, then yeah, I would go down to 30, because that's, down the number line from 31. Down the number line from negative 31, going 1 down from that would be negative 32. So anyway, 8x equals negative 32. We've already said we're going to divide by 8. So let's not worry about this just yet. Let's just write x equals, because 8x divided by 8, that's just x. Negative 32 divided by 8. So this is a negative divided by a positive. Now, hopefully you're able to remember that the rules are basically this. Let me just draw out this little table for you. So I'll put a time sign in here. Now, we talked about this in class a lot. A lot. A positive times a positive is a positive. A positive times a negative is a negative. A negative times a positive is a negative. And a negative times a negative is a positive. So let me remind you of why that is. If I have a lot of positivity, if I add a lot of positivity, then I'm feeling really positive. If I add a lot of negativity, I'm feeling really negative. Really negative, sad. If I take away a lot of positivity, I'm feeling negative. If I take away positivity, I'm negative. And if I take away a lot of negativity, so if you're feeling negative, you're feeling down, you're feeling sad, and I come in and I take away a lot of your negativity, you're going to feel more positive. So this is a table that's very much worth remembering. And the point is that this is true for divide as well. So not just times, but divide. So I could have written divide here as well. Divide or times. Bit easier to explain with times, but it's also true for divide. So negative 32 divided by 8 is a negative divided by a positive, which is a negative. So all you do is you work out what 32 divided by 8 is. So you work out, you kind of ignore the minus sign and you just work out the answer. So 32 divided by 8 is 4, but it's going to be negative 4. And there we go. Right, where are we up to? 15 minutes. I'll just skip ahead until we get a question with some brackets, I think, are in this Hegarty task. So here, I would add 1 and divide by 5, and I should get a fraction. So I'm not going to go through all of them. Okay, you have to do some work. I'm hoping that my explanations have kind of been clear enough. I just want to kind of end the video, as it were, by just making sure that I've addressed what happens when there's brackets. And I might like to skip until I find one that's not got negatives involved. Maybe they all have negatives involved. We'll see. Right. This one didn't have any negatives in it. And it's not that I'm specifically trying to avoid a difficult question with a negative or anything like that. It's just when I go through the first example, I want it with positives, and then we can talk about a one with negatives in. Okay? So 42 equals 7 lots of x plus 5. Now, there is one option that involves straight away dividing by 7, and that actually would make this quite easy. But it's not the method that I'm going to kind of teach you right now, because what I need you to be able to do is also practice expanding brackets. And when you can do it this way, it's then going to be easier to think about it the other way. If you're already happy to see that this is 7 times like something, so because it's in brackets, it's kind of like one thing. 7 times something is 42. So you might already think, well, that something's got to be 6. And so therefore this x plus 5 has to be 6, and you can go from there. That's absolutely fine if you're confident with that. In general, though, to begin with, I'm going to ask that you expand the brackets. So, you see these brackets here? We're going to expand them. So I do 7 times x. That's 7x. It's a plus. So it's a plus. 7 times 5 is 35. And that's still equal to 42. That bit hasn't changed. And so what you might do now is, you know, a lot of people would like to write it the other way around. You don't have to. You don't have to. You want the 7x by itself. So you want to get rid of the plus 35. So I'm going to take away 35 from both sides. And that's going to leave me with 7x equals 7. And then I'll divide by 7 to get x equals 1. Which is what you would get if you were trying to make this bracket equal 6, right? 7 times 6 is 42. So the x had to be 1. To be 1, add 5 to make the 6. Hopefully I've not said too much there that's confusing. If I have, I apologize. I'll do another example where I don't talk about the other method at all. I'll just expand the brackets and we'll answer it. So let's just answer that. Probably the next one has a minus in it. Great, right. So the next one has a negative in it. So we're just going to expand the brackets and go from there. We won't talk about the other thing. So negative 3 is 3 lots of x take away 10. So all we're going to do is, this bit's still the same, but I have to expand the bracket. So 3 times x is 3x, and 3 times 10 is 30, and it's a takeaway, right? It's still a takeaway. And now I just answer this question like how I've been answering the other questions. So let me put it on this side. And then have a think about what I would do. So I want the 3x by itself. Remember, this is always the aim. You want the x term to be totally by itself on one side. So you do things that get you towards that goal. To get us towards that goal, we're going to add 30 to both sides, because at the moment I've got to take away 30. I don't want that there. In order to get rid of that from that side, I'm going to add 30. I can't just add it to that side. I have to add it to the other side as well. This side is literally 3x. The idea is it becomes much simpler. It's just 3x. If I start all the way down at -3 on the number line, but I add 30, I do 30 jumps going up the number line, I will land on 27. Notice that's the same as starting on +30 and taking away 3. So this is one of the big advantages of making sure the sign sticks to what comes after it. So this is a -3, but you can also think of it as a take away 3. So, depending on which way is easier. But anyway, 3x equals 27. Divide by 3, x equals 9. So let's try that. There we go. Right. We'll skip that one. And this one should be fine. Should be okay. So expand the brackets, take away what you need to take away, and then divide. So hopefully you're beginning to spot a bit of pattern with the routine. Okay, the method is really similar for each question, just the numbers, and then you have to be careful if it's got negatives. But the method itself is the same. So that's Hegarty task 178 and 179 both dealt with. The questions that are coming up, if I just click on preview, let's just see the sort of questions we have. So we've got ones that involve division, so that might be a video just to itself. That might be a video to itself. I'm just trying to estimate what videos. I mean, I know I could do this without it literally being part of the recording. What are you going to do? And you see, these are quite tricky. Like there's, I'm not. Let's be clear, these are quite tricky. I'm not suggesting they're not. Like they are quite tricky. You see, these ones here on task 184 is easier, I think, than task 183. So what I'm thinking is it's between 3 and 4 more videos. So well done if you're just sort of powering through them. I mean, don't feel like you have to watch them all in a row. Like, watch whatever, have a go at the Hegarty tasks, get in touch via email if you've got any questions, and then when you're feeling confident, move on to the next one. There's not actually a rush, okay? There's not actually a rush. So, leave a like if this has been useful, if it's been helpful. Send me an email if you've got any questions. And yeah, I'll see you in the next video.